is arcs and central angles. If we have a circle, and the center we'll say is O, if you want to talk about a central angle, then you are talking about an angle with a vertex at the center. So a central angle So Branson, if I draw points A and B, and then I draw this angle, APB, is that a central angle?
Yes. No.
Read the definition.
Angle with the
Vertex.
Center circle.
The vertex of this angle is P.
Yeah, it has to be O.
It has to be O that is the vertex of the angle, right? So, let me take this angle off. That is not a central angle. If this is A and B, then this is a central angle. What we can talk about is the measure of a minor arc and a major arc, and we're going to get there. But to begin with, angle AOB is a central angle. Now, when you draw a central angle, it cuts two arcs out of the circle. This arc right here that is inside the angle is called a minor arc. An arc, by the way, is the two end points, A and B, and all the points on the circle that are between A and B.
Is a major arc more than 90?
A major arc has to be more than 180. So we're going to get there, though. We are going to get there. So, yes, that would be called a semicircle. Yep. A 180-degree arc is a semicircle. Okay. So, arc has endpoints on the circle. And includes all the points in between the 2 points. All the points on the circle, I should say, in between the 2 points. You name the arc by the endpoints. So this arc I have right here is a minor arc. We'll talk about what is a minor arc just next. And you can name it by its endpoints if it's a minor arc. Okay. Now, there is another arc with endpoints A and B. And it is the arc that is outside that angle. See if I can stick on the circle as I draw this arc. Not doing a very good job. But this right here is another arc that has those endpoints. This is called a major arc. In order to name a major arc, you have to name the endpoints as well as a point it goes through. You can't just name it by the endpoints. So if this point P is right here, and this arc goes from A through P and then to B, We would call that arc A, P, B. You only need 3 points, and the ones on the edge have to be the endpoints.
Does it have to be 3?
It has to be 3. Only 3 dB. This right here can be done only if it's a minor arc. Okay? If it's a major arc, then we have to name 3 points. Now let's talk about what is a minor arc versus a major arc. I've been using the terms, we haven't defined it yet. In order to define what is a minor arc and a major arc, we need to talk about how you find the measure of an arc, or how many degrees an arc is. The measure of an arc will be equal to the measure of the central angle that cuts that arc out of the circle. So the measure of an arc is equal to the measure of a central angle that intercepts that arc. And I'll have to define the word intercept because it's a new word. So the word intercepts is a new word. In the word intercepts, there are 2 root words, inter and then septs. The word sept means cuts out, and inter carries the idea of it being inside. So intercept means cuts out and is inside. You can see how this angle AOB intercepts an arc AB. It's what it cuts out of the circle, and it's what's inside the angle. So I would say angle AOB intercepts arc AB. Put that in a parenthesis. It's kind of a sentence that goes along with the definition. If this angle then is 50 degrees, then arc AB will also be 50 degrees. We would say then that the measure of arc AB equals 50. It is the angle with the vertex at the center that gives the arc the measure.
So you can't count when
No, it has to be with its vertex at the center. Now, this minor arc has a measure of 50 degrees. What is the measure of the major arc then? How do you know 310? Because a full circle would be 360. Yes. So when we go 360 minus 50, we get 310 degrees, and that is the measure of arc APB. Notice the little m again for measure. If you want to talk about how many degrees an arc's measure is, you use a little m in front of the arc. So measure of arc APB is 310 degrees. Okay, now we're ready to talk about what is a major arc and what is a minor arc. We're going to write the definitions. But what would you say makes an arc be a minor arc versus a major arc? Just thinking about it. Yes. So a minor arc is an arc whose measure is less than 180. Move this over here so that I have a little more room. I want you actually not talking. A major arc then is what?
More than.
Yes. So then the question would be, well, wait a minute. What if the measure is exactly 180? Because that would neither be a minor arc nor a major arc. And that is called a semicircle. You are correct. A semicircle is an arc whose measure is 180. All right. Now we have arc addition postulate, postulate 16. Postulate 16 says the measure of the arc formed by two adjacent arcs is the sum of the measures of those two arcs. So in our diagram, the question might be, first off, what is an adjacent arc? So if I have 3 points on my circle, A, B, and C. If you have two arcs that are side by side and do not overlap, so they share only an endpoint. Here, these two arcs share point B. Then arc AB and arc BC would be adjacent arcs. Because they only share an endpoint. So they're side by side and they don't overlap. So I couldn't say arc AC and arc AB. Those overlap, right? It has to be AB and BC. That are the adjacent arcs there. Now I know that the measure of arc AB is equal to whatever this angle is. So if that's x degrees, arc AB is also x degrees, right? And I know that the measure of arc BC is whatever that angle is. So if that's y degrees, then arc BC is y degrees. What this is telling me is that the measure of the arc that's formed by these two adjacent arcs, the measure of arc ABC, I'll call it, you can name an arc by 3 points if you name the endpoints on the edges and the middle point to the middle. Okay? It does not have to be a major arc to name it that way. So the measure of arc ABC will equal the measure of arc AB plus the measure of arc BC. And we can see in this diagram that makes sense. Because x plus y gives you the measure of angle AOC, then the measure of arc ABC will equal x plus y, which is the sum of the measures of those two arcs. Congruent arcs have to have two things to make them congruent. Congruent arcs have to have the same measure, but that's not enough for them to be congruent. Let me explain why. Let's say I have this circle. Exactly. And we have an arc formed by A and B on this circle. And the central angle is 60 degrees. Now, what I'm going to do is enlarge this circle. So I'm going to clone it, if I can. Try again. Clone. And enlarge the circle. Change the names of the endpoints to C and D. Are these two arcs going to have the same measure? The measure of arc AB is what? The measure of CD? But are the two arcs congruent? No, because take arc CD. In order for it to be congruent to arc AB, when I move it over here, it would have to lie exactly on arc AB, does it? No, the endpoints would have to match up, right? How about taking arc AB, moving it over here? Does it match up with CD? No, the two arcs are not congruent. Their measures are the same, though. Here, I would not say arc AB is congruent to CD.
It's equal to.
Their measures are equal. If I put a little m, I could put an equal sign, but they are not congruent. So if you go congruent with a slash through it, that means not congruent. Okay. You could talk about their measures being equal or similarity type ideas. So now, congruent arcs. There are two things that must be true. They are arcs that have the same measure that come from either the same circle or congruent circles. Now we have theorem 9.3. In the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent.
So they'll have to be the same size for individual congruent arcs.
Exactly. The reason why theorem 9.3 works is because, by the way, you recognize the if and only if?
If and only if the pseudo
That means a biconditional. That means you can write two conditional statements. So, what are these two conditional statements? If same circle or congruent circles, two minor arcs are congruent if, or let's see here, this is if, then their central angles are congruent.
You write a conditional statement or two?
Two conditional statements. And the other statement, and both of these statements, by the way, are direct results of definition congruent arcs, so I'm not going to do a proof. But the other statement is if central angles are congruent, and you're in the same circle or congruent circles, then the minor arcs are congruent. So it works both ways. If in your circle the two minor arcs are congruent, here is A, B, and we have that arc. Let's clone it and rotate it so that it fits a different part of the circle, if I can get this thing to cooperate a bit. So those two arcs are congruent. What does that mean about the central angles? That the central angles are congruent. Yes. And vice versa. If you make congruent central angles, the minor arcs will be congruent. That's what this theorem is saying. And it's a direct result of definition congruent arcs. So I'm not going to do a proof. Okay.